on the website. Okay, and so today's topic is audience analysis, and what this involves is your relationship with your receiver. You're the transmitter, and somebody else is going to receive it, and so it's your familiarity with your receiver that makes the process work or fail. And so today we're going to figure out how to make that process work. And so audience analysis, and you can ask why you want to study this topic in the first place. As I said, a lot of writing courses don't talk about this, and that's unfortunate because this is a really important second step in the writing project. Every document that we write is created for somebody, some target audience. For example, if you take a very, very simple thing like a microwave oven, how to use manual, that manual is designed to work with people who purchased the machine and they want to know how to use it. So usually your audience are like that, targeted, very sharp. And so then you need to tell them how to turn the power on, how to cook something, and what are the safety issues, et cetera, et cetera. And so, but you don't necessarily have to go into the details of how the microwave radiation is generated, how electrical power is converted to microwave radiation, and how that radiation interacts with the food, and how the food gets heated up, and how that results in cooking. All that is not necessary. The user doesn't want to know that. They want to know how to make this or that, and give a recipe and tell how long you eat, which button to push for this or that. So if it doesn't work, then you have to tell them, look, you call me, or you call service or whatever, right? So you don't tell them open the microwave and remove the magnetron and then replace it, the condenser and all that. You don't do that. It's right. So the audience analysis is necessary. You can't put everything in there, and you need to put in what the audience really require to move ahead and do things. So every document is created in that way. If you take a journal article, then the readers of that journal are your audience, and they could be scientists, engineers, or technicians, whatever, or students and whatnot, depending on how the journal is printed and circulated and so on. You need to know what that is. Chemists, biologists, and so on and so forth. So if you write the paper to the wrong audience, the journal will reject you, right? Even before even reviewing it. So it's really important these days to figure out who your audience are. So that's one of the reasons to study this particular topic. I'm going to show you some examples how you figure out who your audience are and how do you adjust your writing to them. So you want to know your audience. What does that mean? It means you need to know what they're interested in. Okay, that's really important. In case of microwave manual, they're interested in making their food with it. So they want to know how long to cook and how to cook and so on. And their skill level. So in a microwave business, you can assume that they have fairly low skill level in terms of electrical appliances. They know how to turn on and turn off and plug into the wall and remove from wall and things like that. So you assume that is a reasonably good level. You don't assume them to be electrical engineers, for example, right? And familiarity with the topic. How well do they know about their microwaves? A lot of them don't, because these days microwaves have become very complicated and black box. Sometimes you don't know whether you're pushing seconds or minutes, and every microwave is slightly different. You have a little pad or a little button saying chicken, and you press the chicken button, then it cooks the chicken and so on, right? So people are trying to figure out how to make. So you need to figure out that's all they would know. Then you won't expect them to know any more than that sort of thing. So you really need to understand your audience. Audience have specific needs, and there are specific audience for each topic. And so just as a microwave example, Journal of American Chemical Society. Now I'm going to the other side of the equation. The Journal of American Chemical Society is circulated among mostly chemists and biologists, some physicists, but mostly chemists. And the journal is also circulated among almost all chemists, physical chemists, inorganic chemists, organic chemists, and whatnot. So it's a general audience. So you need to write, there is the other one. Yes, we're hoping that student will come in. And so when you write the article, you cannot assume your audience are going to be organic chemists or physical chemists. So you need to write general audience. So this is really important. And a lot of the time papers are not published in this journal because it is too narrowly focused. And others, what that means is others cannot understand what you have written and may not be interested in reading even. And so it is very, very important, and it's tough to write to general audience. Same with science, nature, right? These journals are very top tier journals, and science, all different scientists read it, right? Not just chemists, physicists, biologists, geologists, astronomers, and so on and so forth, and mathematicians. So when you write an article to science, you have to figure out how you're going to do that, how you're going to explain it to all these other people. So you're going to lose a lot of audience. I mean, there's no way you can get all of them, but there has to be enough width in your audience presentation that you can catch many of them, not lose them. Otherwise, they won't publish the article. So audience is segment. So for every document, there is a segment of audience that you need to pay attention to. So write has sufficient about them. So then you tailor the document. Once you know what they're interested, what they like, what they don't like, et cetera, and we're going to go to the analysis step by step, then you change your document to fit into that. Sometimes I ask you guys, write a paragraph for high school students on this experiment. Write a paragraph to Gen Chem students on the same experiment. And write a paragraph to graduate students on the same experiment. So you're going to modify, you're going to tailor your document based on your audiences. And so you have to learn that, learn how to do that, what to change, so you can address different kinds of audience as needed. And this is central to successful communication. If you don't know who your audiences are, if you don't tailor your document to your audience, your communication is likely to fail. And we see the department seminars many, many times. Speakers come in and they talk as if they're talking to specialists in the field, but it's a generally chemistry audience. They don't know all this stuff that they're talking about, and it's very hard for a chemist to follow. If you're not in that special field, then that seminar is not going to be useful. So those speakers who recognize that, and then they say, hey, I have a broad audience, so I need to really explain my research, even the very focused research, but I have to explain it in general terms that organic, inorganic, physical, analytical, polymer chemists, biochemists can understand what I'm saying. And so that's tough. So this is how if you want to talk in the biology department, the same issues. So no matter what. So successful communication requires that you tailor, you think about it before you start doing much about it. And the time and effort you spend on this particular aspect, which is not mentioned by most people in the field, is actually worthy. Because in the end, your communication will be very successful if you spend a lot of time on this and figure out how to do these things. So that's the reason we want to spend a lot of time on this particular topic. Generally, there are 4 types of audience. This may not be true. It's just, just categorizing. So let's say 4 buckets. And put all the audiences into these 4 different buckets. One is, in general, experts in the field. And so I was saying, the Journal of American Chemical Society and the major players there are experts in their fields, and top organic chemists, physical, inorganic, et cetera. And so they are experts in their own field, but they're not experts in other fields. That's something we need to keep in mind. So these are experts. What does that mean? It means they know inside out about the the fundamentals, the practice, the mechanics, and history, and what's going to happen in the future, whatnot. All that stuff, they seem to have a pretty good idea, and they are the ones that are at the top of the professional fields, and so they're experts. And then you have executives. So this is admin. And admin admin, they are removed from the day-to-day aspects. They're removed from, nitty-gritty details. And so they may or may not know what we're talking about. So they're a very different set of people. And you need to tailor your document. If you're writing to the dean or the president of the university, you have to write a letter. You have to write a letter that way they can understand it. This is really important. How do you do that? So the dean doesn't know physical chemistry. So if I have to explain some issue with physical chemistry, I have to explain in general terms, and so on. So that's executives. And usually they spend very little time, doing anything specific because they have so many things to do. So for each task, they get very small amount of time. So you need to write in a way that you can communicate with them in a very short amount of time. Editors of journals, for example, fall into that as well, the deans and provosts and so on and so forth. Then you have technical staff. And the technical staff are the other side of the equation. They know inside out regarding how to implement something, how a water pump works, how the switch gear works, or how the turbine runs. So they know how to do it, and they know how to run it, and they know how to maintain it, and so on. They may not know the theory behind it. They may not be experts in the field in designing a turbine, for example. And so for them, you need to write differently. And so that's the technical stuff. And lay citizens. And most others are lay citizens. What that means is they need not to be lay citizens, means that not that they cannot read or write. That's not what we mean. What we mean is in terms of their familiarity with the topic. For example, if you're talking about plastic pollution, most people don't know what it is. So most people fall into this particular category of lay citizens. So you may be surprised how that is. And so what I'm trying to say is that even an expert in say physics or biology or chemistry may become a lay citizen as far as we're concerned when we write the document. So if you're outside your field, right, you're a lay citizen. For example, PhD is famous. We say this all the time: 1 inch wide and 1 mile deep process. So means they go into such great depth on a very, very narrow topic, right? So they're experts in that particular topic. They're probably the only ones that know so much about that topic in the entire world. Nobody else knows as much as they do. And only then, of course, they get their PhD. So what that means is when you go outside that specialized topic, they are lay citizens. Okay, so PhD doesn't mean they know everything. Nobody knows everything. They know everything about very, very small piece of knowledge or science or whatnot, whatever it is they have specialized in. And beyond that, they're not specialists. So we say this, an expert is one that knows more and more and more about less and less, and less and less amount of information. They know more and more details about less and less, and are more and more focused piece that they know almost everything about nothing as a mathematical limit, right? So that's an expert. So one very fine detail they know everything about. The rest of it they don't know much about. So that's an expert like that. So lay citizens are backwards because then outside that field they're lay citizens. So identification of these into one of the 4 categories is useful, but it's not enough because you may have mixed audiences. I will show you how that is, and then how you tailor your letter. So here is an example of who are your audience. For example, in this particular course, when you're writing, right? So in your course, your classmates and your instructors. So instructors fall into the category, they are your audience. And your classmates are your audience. You're writing your document to your classmates. And unless you're writing a research paper, you're writing a research paper, then you have mixed audience. You have your classmates, you have instructor, and the journal readers, whoever read the journal, they're also your audience. So consider all other students other than in this course, in other departments, and they're all lay citizens as far as you're concerned. Okay. And many faculty are lay citizens as far as you're concerned, because they don't know much about plastic pollution. And so based on what topic you pick, your audience get defined. And your assignment may have defined audience such as university community. So if somebody else gives you an assignment, they will tell you, okay, write a letter to the university community, write a letter to the citizens of Mansfield, and like that. So then you may have a mixed audience and other things. So you need to pay attention to what my audience. Mixed audience is a challenge, but we will figure that out how we're going to do that. So when you identify your audience, then we can analyze their characteristics. And that's what is called audience analysis. So first is identification of the group or groups of people that are going to read or listen to your story. So that's the first thing. And then what do you do after that? So you find out what my audience may already know on the topic that I'm writing. Usually not much. That's the short answer to the question. But most of the time we don't write that way. That's why communication doesn't work as well as it should. Because for example, one assumption you can make, I will show you exactly how to go about answering this question. One assumption you can make, and this is a very safe assumption, that what you know about the topic is not what everyone knows. Okay, because after you've read, you've read so many papers and everything, and you collected all references and understood a lot of stuff, and you discussed in the class, and then you're writing your topic, then a lot of people didn't do that. So they don't know a lot of stuff that you have accumulated during the project. So most people don't know what that means. Okay, that's a good assumption to make. That when you're writing what is a microplastic, for example, don't expect everybody to know. We define in the class, and so you know it, and maybe some people in the field would know it, but general audience, other classmates and other students, faculty won't know what that is. You can make another safe assumption, and these are like, really your safeguards. Another assumption is that whatever you knew in the beginning of your topic, in the beginning you research on the topic, and is the only thing that other people also know. Okay, so remember that. Remember what you knew about this topic before you started working on it. So whatever that you knew, that's a safe pool that you can say, hey, a lot of people might be at the same level as I was when I first started reading, particularly a topic like this. Is contemporary, it's evolving, and it's really important, but not well known in the literature. So those, after you made those assumptions, we're still not ready yet to know who your audience are and how to deal with them. So what I would suggest then is to interview, right? So what does that mean? It means that, you can sit one-on-one with them and discuss. So now how many can you interview, right? So ask one of your friends, hey, come talk to me about this. So let me tell you what I'm trying to do, and tell me what you like, what you don't like, and then you can discuss what you understand, what you don't understand. So you can interview people that you have access to, right? So you may not have access to a faculty member, but it's okay if you could find a faculty member and you can interview them. That's great, actually. And if you take that step, that'll be awesome. So the point is that, in politics, people do this all the time, right? They have focus groups. They bring in 10 people, 15 people, and then, cross examine them or ask them for feedback, make presentation, then tailor everything based on those feedback from 10. So the interview is a good way to know about your audience, okay? And so that is on a chat in a social setting so that they're relaxed, coffee break or something, so they can actually tell you more about themselves, what they liked about, etc. Use yourself as a negative control. What does that mean? Means that if you don't know something, right, it's safe to assume others also don't know. Or at least if you didn't know something in the beginning of starting the research on this topic, you can assume safely that others also don't know that same thing. So use yourself as negative control, make those two assumptions, and then interview. Interviewing is a difficult stuff, may or may not happen, but that's a really good way to know. And what I'm trying to say is mirror yourself. And that is, as you prepare your topic, highlight the facts, data, etc. And the things that you had difficulty with, say, for example, integral calculus is difficult sometimes, right? You may have encountered that. Then when you're teaching integration, you want to pay extra attention to your students. Say, hey, this is a tough thing I know because I went through this. I found it difficult to learn. Perhaps it's also difficult for you. So I'm going to explain this in simpler ways. So mirror yourself. That helps a lot. And so whatever your past experiences are, when you're reading a paper, you find it very hard to understand it. But you're going to write an abstract or write a thesis or something on it, then it's going to be tough for others also to understand that content. And so you have to pay extra attention to how to simplify that. So mirroring yourself works a lot. And I do this so much in my own research papers. And I mirror myself, and then reviewers seem to like that. A lot of reviewers don't know a lot. And so you need to really explain it to them in simple terms. That's the key, in simple terms. So then next question you ask is, okay, now I have some ideas, I have some tactics I'm going to throw at my audience and try to figure out what they are. So now you start asking slightly more detailed questions, next level of questions. What do the audience expect? In short, a lot. Why? Because these days the demand is very high on the side of the audience. They want everything to be beautifully orchestrated, very well organized, great colors and everything. The language has to be very simple and exact, and there should be explanations, and there should be no complex equations. But if you do have to have complex equations, then you have to explain it in a really nice way that they can understand it. And so they expect a lot these days about all the science communication. It's only getting worse with time. And so if you don't have a title, okay, all right. So if you don't have a title for your document, you want to make a title, working title, and then you can start to work out the details, what to expect, what not to expect. Look at the title of your document and imagine, what would the audience expect to know on this topic? So plastic pollution, what would they want to know? Well, they want to know, why should they read your article? That's the first thing, right? So what is the importance of this topic? That's the thing. If they're not interested, they're not going to do it. So, and then you have to tell them in the very beginning itself, the reasons why they should read it. And this is really tricky, because you can't tell them, hey, you read this, only then I will reward you or whatever, right? So, but you have to tell them in a way that they will unknowingly start reading your document with great intensity and interest. For example, you can put in some dramatic sentence in the very beginning, right? And that doesn't mean not true, but you need to have a true fact to make it dramatic. That's well established. For example, plastics floating on the ocean currently occupy the same area as the state of Texas. So this is a huge problem. So now suddenly everybody's interested and say, wow, I mean, that's a lot of plastic. How did it happen? What is this consequences of this? How is that going to affect me? Right? So everybody's looking about themselves and say, hey, what's going to happen to me? And some people look and say, what's going to happen to the environment? And some others look and say, how is this going to happen to animals? How is this going to affect the plants and weather? And different people are asking. So, but for all of them, this is a threat. Seems to be like a threat, and we need to take care of that. And so people say, oh yeah, no, we can't allow this to keep growing like this. And so they may get interested. Same with cancer, same with heart disease. If you're writing an article on heart disease, you can say half is the second most important cause for death in the United States. And so then suddenly everybody's interested. You can say, well, 30% of the people die of heart attacks. Wow, 30%, that's very huge. I'm just making up some numbers. So you need to start with a fact that motivates your audience. So that's really, really important, okay? So like tip of the arrow, it needs to pierce through. And they would like to know what is the importance of the topic and the reasons why they should study. Next, they want to know what will benefit them. Okay, that gives you motivation. And use it as a segue to get into their mind and start telling them, look, you need to learn this. You need to be aware of this. So what benefits would they read? So you tell them, once you read this, you would know how to reduce the plastic pollution or reduce your exposure to microplastics or minimize your health, effects, deleterious health effects if you read this, my article. And so they say, okay, so this is going to be a benefit for me, so I should read this. So point out the benefits in the beginning itself, right? You solve this problem, which has these dividends coming out of. And then they expect details, explanations of terms, concepts, equations, etc. So this is really important. We'll get into, now we're getting more and more details about how you tell your story to them and give examples, and they really expect a lot of examples, each and every way. And then they want clear sentences. If a sentence is too complex, they're going to skip that and go to the next sentence. Okay, so then you lost them. So if you want them to read continuously, each sentence has to be nearly perfect. And only then you can actually, keep pace with them. Otherwise, they will be left behind. Clear sentences, simple arguments. This gets a little dicey. What is a simple argument, what's not, and I will let you figure that out. And you will get this by experience, writing a lot more. Then you start making simpler and simpler arguments to put forth your points. Because this is a science document, which means they will have data, it has analysis, and then you place logical arguments based on the data and analysis. This is what is happening, this is not happening, this is the reason, this is not the reason, so on and so forth. So then they also expect a visual impact, very high visual impact. Unless you have cool graphics, people are not reading anything anymore these days, right? So you see articles, pages and pages and pages of text and equations, but no figure, nothing. I don't read that myself because it's too hard for me to keep going without visualizing something. And so I suggest one graph or one figure per page that you're going to write. I mean, that's a lot, but that's maximum. But even if you have one per every 2 pages, it's okay, because I want to look at a figure and then read. So this way it keeps my focus onto the subject and hopefully cool graphics. And that's what people are looking for. And they also want error-free state-of-the-art document. If it's stale, they're not going to read it. If there are too many errors, they're not going to do it. So in other words, if you have spelling mistakes, errors, punctuation problems, grammar problems, and these are non-technical problems, right? So even if you have those, they get uninterested in reading it, and they leave the document and without reading it. And so even small things like missing full stop, missing comma or something, really turns them off. And I say this, I think there is some sort of a saying, death by 1,000 cuts. So if there are too many of those, then people won't read it anymore. They just give up and move on to the next page, and then to the next page, and so if they continue, then they will quit the reading altogether. So you got to have all these little details worked out, and we're going to spend a lot of time applying these rules. So what do my audience know about the topic? So that's the question really you want to answer. Get to know your audience. And what they may not know, that's really important to know. What do they know, what they don't know? We discussed this already. If you didn't know certain things when you started reading, most likely your audience also didn't know that. If you learn something new, that also they didn't probably knew when they start reading. What would be interesting to them? So this is really tough. And as I said, if you're a top chemist, you're interested in chemistry. If you're a physicist, you're in physics, etc. in general. But you have to go beyond that. And you have to go deep into the nitty-gritty details about what they're really interested in that particular part. And this is a very, very tough thing to do, to figure out what they're interested in. That's why interviews help. Focus on what the interest is, what they like and dislike. Most people like graphics, and you can say that most people dislike equations. Okay, this is general, but there are some people who really need equations in them. Without that, they're very unhappy. So you have some equations for them. But you can explain the equation using a graphic, then you got both of them on board. Then you have equation, those who like equations are there, those who like graphics are also there, and you connect the two together, then you have a good combination of the two things. And what would the benefits my audience, how to articulate the details, so on and so forth. There's so many questions you can ask, and it depends on you, how much you want to think about this, okay, and how much you want to prepare about your audience. And a lot of people don't prepare, as I was saying, about the audience, and so that is a disaster in making. And so more time you spend thinking about this and preparing for it, more successful is going to be your talk or your document. And in the end, this is the final question: how to read the minds of your audience. So how do you know what they don't know, what they like, what they don't like, what are the benefits they will expect to have from this, and why should they spend this much time reading, all this. So you're getting into their minds. It's a psychological thing, it's you get into their head and start manipulating. So that's what a good writer does. A good writer gets into your mind and then start manipulating your thoughts. Say, think about this, not that. This is beneficial, not that. This is what you really like. Think again. This is what you really like. So they start telling the reader how to behave, how to go forward, and how to go around reading the document. And so without their knowledge, of course. And if once they figure that out, they're not going to read it, they'll be upset. So it's all sublingual, between the lines kind of thing. So we'll show you some of the tricks. So here is an example. Here's an example for Gen Chem students. So here is a graph. And I'm going to say, hey, how do I write a paragraph explaining this graph to high school students? Excuse me, Gen Chem students. This is for Gen Chem. Next slide is for high school. So what do we have in the graph here? This is the first thing you need to think about and say, first understand what it is, right? That you're trying to explain it. You have x-axis here, you have y-axis, and you have a function. Okay, that's the mathematical function going through this way. Then there is a little h, and so on everywhere. And so this is a hydrogen atom, that is another hydrogen atom. And at this distance, internuclear distance is x-axis, increasing. So apparently these two hydrogen atoms are very far away. They're not interacting with each other, they're free atoms. And on the y-axis, you have energy with units. It doesn't matter what the units are, so with energy. And then you see this dotted line here. So that is zero energy. So that zero energy corresponds to the energy of the two hydrogen atoms here. Okay, that's what the author intends. Author intends you to think that the energy of these two hydrogen atoms is given by the dotted line, which merges with the solid line at infinite distance. So they are then supposed to be free hydrogen atoms. They're not interacting with each other, their interaction energy. And as the internuclear distance comes smaller and smaller, means the two hydrogen atoms are approaching each other. So here they're slightly farther apart. Here they're slightly closer. Here they are even closer. And then they're even closer here, right? So what the author is saying is that the energy of the system at this far away distance is like this. The energy of the system is like this when it is somewhere around here. And the energy system is like this when it is around here. And then energy system starts to increase when you compress them further. So what they're trying to show is that as the internuclear distance is changing from infinity to zero, the energy of the system is changing. And this is because of interactions or whatnot, bond formation or whatnot, whatever you want to say, that's okay. And in addition to that, there are a couple of numbers given by the author. It said 0.074 nanometers. The units are given. So this is a good author. They gave not only the numbers, but also gave the units for the number. So that's the length, right? That's bond length. It's written as bond length, HH bond length. So they're explaining with a little arrow, that dotted line, that's corresponds to the bond length. And we will see how that is not exactly the bond length, but anyway, we will talk about that in a few minutes. And then there is a horizontal line drawn here on the y-axis and showing that minus 458 kilojoules per mole, right? So whatever. So that means the energy of the system at this level, at this bonding, the bond length is that minus 458 kilojoules per mole. So what the author is intending to say is that if you start here, zero energy, as you move closer and closer the two hydrogen atoms, the energy starts to decrease, and you have a negative number here. And then it begins to increase. The energy begins to increase. And again, becomes zero at some point. It's a very compressed state, and the repulsion is trying to raise the potential energy of the system. By the way, this is the potential energy of the system, but you can call it energy or bond energy or interaction energy. It doesn't matter what you want to call. So that's what the author is intending to tell us. Okay, here the distance is zero, energy is some large negative number, and this reaches zero, distance at infinity asymptotically, and also same thing, asymptotically reaches zero on this side. So this is what the information is, and now we need to explain this to Gen Chem students. They may have seen this sort of thing before, but not likely, and they may know what the bond length is, but not necessarily in this way. And this energy gap that is given from 0 to minus 458, we know, of course, is the bond energy. They may know bond energy, but they may not know in terms of what it is with reference to independent states and whatnot. Okay, so we keep that in mind. So they are Gen Chem students, and so they have some energy, some idea about energy, some idea about the bond length, the bonding, and hydrogen atoms, and periodic table, and that sort of thing. And so now we analyze this. So let's take this piece and analyze, what do my audience know about the topic? And they probably are told already, electron pair bond. This is very, very common news, Lewis structure bond, electron pair bond structure. Electron sharing by nuclei. So when the two hydrogen atoms come together, the electrons are shared. We tell them that. When they share, the energy drops. We tell them that. So they might know that already. So that's something we can make use of. What they might not know. They might not know exactly what the bond length is. And bond length is actually equilibrium bond length. We'll go into the details of that in a moment. But anyways, that's the bond length corresponds to energy where it is the minimum energy. Longer than the bond length, energy increases. Shorter than the bond length, energy increases. So they might not know that. Okay. So they may not know exactly how the bond length is defined. It's not static, it's changing, it's time. The molecules are vibrating, so the internuclear distance is changing. So there's the equilibrium bond length, not exactly bond length is. So they may not know all that. They may not know bonding, chemical bonding. They may know about the electron pair bond or maybe valence bond and things like that. And they may or may not know what the bond energy is. So what would be interesting to them in this, right? This looks like a plot and a graph, and it looks nice, black and white, but nature of the chemical bond. So it might be interesting to some of the students because they're really fascinated by what really binds the two atoms together when they come close enough. There's something mesmerizing going on in here. So they may be interested in that. So you can explore that avenue and see if they respond positive, or they may want to know why chemical reactions occur. This is a fundamental question. A lot of people know why is the sky blue? Things like that. Why is there a stone? If you throw it out, why does it fall back down? You can ask these simple questions, and people are interested in answering those questions. And so you can go by that sort of deal as well. Why do reactions occur? So when the two atoms come together, reaction is happening, and because energy is dropping, and so you always say, hey, this is more stable than isolated atoms. So they want to think in terms of stability. They want to think in terms of energy, etc. What do they like and dislike in this? So they like because it's a very simple graphic. Okay. So it's a little complicated, but simple by a lot of measures. It's simple graphic. What they don't like is usually a complex equation. This is a Morse potential. So we could have written an equation describing the Morse potential. But when they look at the Morse potential, they won't understand, the meaning of it, or what does it really, tell us, and does it really tell the bond energy, bond length, et cetera, out of it. Yeah, mathematically you can get all that stuff out of it, but not visually. So it's a visual interpretation of that equation. So they won't like complex equations, but if you do give an equation, explain it really well. If you don't give equation, that's okay. They won't mind Gen Chem students. They're more comfortable with the graphs and visuals. And so how to motivate them? They're motivated because they want a good grade. They already paid for the tuition and they're here to learn. And so they're generally motivated. And so if you tell them, cool stories, they will. And they want to understand chemistry. If they don't want to understand chemistry, then it's a little difficult for you, but you tell them little stories, little jokes and whatnot. So then you can also maybe motivate them by saying nature of the chemical bonding is very, very intricate and very hard to understand. It's a challenge that you should master and all that. What were the benefits to the audience? They will learn fundamentals of chemistry and maybe earn a good grade if they learn this, because this may be on the quiz or an exam or whatnot, right? So that's one of the benefits the students are looking for, and how to articulate details that my audience may not like. So Morse potential, for example, is something they won't like. It's a complex equation, but it's explained now as a graph. So you can simply state that this smooth graph is mathematically precisely defined by this function, and that's called Morse potential, which you will learn later on, importance of that in chemistry. So you can leave them at that stage. And so you can try to explain things that they don't like in terms of things they do like. So that's really the key. Once you know what your audience don't like, don't have to avoid that. Find out a way you can bottle the same wine in a new bottle with an attractive label so the customer will buy it. What is at stake for the audience? They're really nervous that this may appear on the quiz, and if they don't understand it, they may not be able to do well, then they may not get a good grade. It may appear on the exam and so on. So this is a real stake for the audience directly right away for the students, Gen Chem students, right? So you're going to give them a question or a quiz or an exam at some point. What would be inspiring? Now, this is really tough. As an author, if you could inspire your audience, you're mega successful. And this is tricky, and you can inspire them perhaps saying, investigating why do chemical reactions occur? Like a fundamental property of nature. And we're going to investigate that. It's a mystery. We're going to solve this mystery. Who done it? And so you can inspire them by telling them who first figured this out, and how this works in nature, etc. How to read minds of an audience. So this is the question we're trying to understand, how we can read their audience. So these are all the questions we are addressing to read their mind. Okay, so that's and so what do they expect? What do they think? What do they remember? What they don't, and what they like, what they don't. And so all that is the inner process going on. And what is at stake? What are the benefits, etc.